Howdy folks, hopefully my tech issues are kind of getting solved. I'm coming to you from E110, so this is our wood shop, and I'm on our Stinger CNC over here, same one as the one that we have across the hall in E111. Right now, I just want to talk about measuring your sheet of material. Again, CNC milling is a subtractive process, so we're going to have an end mill that ends up cutting away and turning our piece of wood into chips, and then our part's going to pop out when we're done milling. Now, we have to measure this because, in my opinion, we want to design around this sheet of wood rather than make something and then find a sheet of wood for it. I have an idea in mind for our project for the day. We're going to design around this little 3D print that I have from a bunch of years ago, probably 5 years ago. One of my students made this in Minecraft, and then we got a multicolor print made in Shapeways. So it's a little bit delicate. We're going to make some sort of shadow box for it. So to our sheet of material. This I just took out of the scrap pile, nothing totally fancy or special. The first thing we want to do is we want to measure our width and then our length. So if we take our tape up to it, we'll notice that we get about like 8.75 roughly inches on both sides. It's a little bonus down here, but that's all right, and that'll work out for us. It has rough cuts on both sides. It looks like it hasn't really been trimmed up or jointed. We don't need to do that because most of this outer edge is going to be waste material, or clamp's going to clamp down to it. It's not going to be used at the end of the day. So 8.75, we got our width. Our length, if we do the same thing, measure both sides, we want to choose the larger dimension sometimes, or the smaller dimension. Depends on how off your piece of wood is. In this case, one side was about like 13.8 inches, the other was 13.75. I'm going to work with the lower just because we're not dealing with a huge part and we're not dealing with a ton of material, so going smaller is better. Next step is for us to actually go from our length and width into material thickness. So we actually have to consider how thick is this piece of wood all the way around the stock lumber. So if you grab your calipers, you can flip them on, zero them. I suggest measuring each corner and each midpoint. And if you work your way around, you'll start noticing that there are some inconsistencies. Multiple reasons that can be a reality. One, when this piece of lumber was pushed through the planer at the lumberyard or the mill where it was made, could be that it was like a little bit of a rough cut. So one side could be a little bit more bonus than the other. What I noticed is around one side, including the halfway, I was getting about 0.755 inches thickness, but then on one side down here, let's say, I was getting 0.76, roughly about that. So if we were to buy this at the lumberyard, they'd probably tell us 3/4 of an inch thickness poplar. We need to measure this because when we go to cut out, we want to cut all the way through this piece of stock and get our part so that it pops right out after we chisel out the little tabs we're going to make. So we're going to work with 0.76. It's the larger number in this case because we want to make sure we go all the way through this piece of wood and we're not left with like a really thin like sheet of paper basically at the bottom of our cut that we have to sand away and all that nonsense. So looking at this again, we're designing around this sheet of material. I got 8 3/4, 13 3/4, and then roughly 0.76 for thickness. So that's our first step. And in a moment, I'm going to see you in CAD on Onshape. All right, folks, take two. I just got distracted by people needing wood getting cut. We're going to start designing in CAD, working in Onshape. And again, we're designing for my little handy dandy trinket that one of my former students made. And this, again, I could design around the file that we originally made in Minecraft and exported and went to 3D print. So this is night sky right there. We're not going to do that though because what can happen, there's a little tolerance difference between what we designed and what actually gets printed. So what I'm going to do real quick, I'm just going to measure out our bounds here for this part. So So let's write that down just so we don't forget it. 2.23 and 2.45 is what I was getting. So I don't want to bore you with that. I'll probably speed this up a little bit. Yeah, 2.45. It's going to be a little bit off because it looks like this isn't actually like a perfect rectangle. Looks like it might be actually kind of sort of a trapezoid. So let's close up our calipers, turn them off so we don't waste any battery, and let's hop right into making something in CAD. All right, folks, so the next step that I want to talk about right now, I have our cutter somewhere. Give me a moment and I'm going to grab. All right. I am back. Hopefully my audio is okay. I have a cutter right here. It is a 1/4 inch cutter. This might actually be too large for what we want to do, but we'll play around with it in a little bit. What I want to talk about briefly is getting perfect edges in your material. If I were to design my box like I have right now, and I were to go ahead and mill it out, in order to get a perfect 90-degree edge on the inside, right, like you see right here, I would have to chisel it out because our drill bit actually is round, right? Our mill or cutter is round. There's going to be a little fillet right here, and I will show you that and what it will look like essentially when we cut it. So if I open up fillet right here and I select this, let's just select all of these inner corners here. All of these inner corners are going to be round. So let's get hop there. Can we hop back to ISO? And then let's make this 0.25 because that'll be more representative of what it will actually look like. That's going to be the inside of our box, and that may not actually work for us. Because again, the part that I'm trying to design for is square. So unless I like sand down the edges, which I don't want to do, I'm either going to have to chop them out with the chisel, which I'm happy to do, or what I could do is design this so it's a little bit larger actually than it needs to be. Another thing that I could do, which is an easier fix, is I can actually like overcut a little bit. We may or may not do that in the 2D Cut Pro. And essentially what would happen in that situation is I would have like a little notch here and a little notch here so that we cut past this line and we have a clear space in here and we could have something inset in there with a sharp 90-degree edge. Hey, so I'm a visual learner, so I just went ahead and made the example. I'm splicing this in here. This is what we designed, our initial design for the box. What I'm describing is basically when you cut out those edges, it'll look something like this. So the cutter keeps going past the bounds of the square so that we can actually fit something in here that's perfectly rectangular with 90-degree edges without having to like manually chisel anything out. So that's what that looks like, and now we'll go back to the video. So For right now, I don't want to bore you too much, and maybe I fast forwarded through this a little bit. This is essentially our part. It's going to be in our sheet of material, and it looks like we could potentially put 2 of them in the sheet. When we get into Cut 2D Pro, we can maybe put 2 in there at a time. We'll play around with it a little bit in Cut 2D. The next step in us actually designing this thing is to get a drawing of it. Now, if I go into my part studio down here, I could potentially export it as an STL. Some programs do take STL. For Cut 2D Pro, we actually need a drawing, so our best bet is to click on our part here, which I should actually rename to Shadow Box, and we are going to create a drawing of it. So we're going to create a drawing on a custom template with no border, no title block, and the goal for us right here is to get a 2D top view drawing of just the box. And what we're going to do, once I get this, not the front, we want the top. Whoopsie doodles. And we want to make sure it's 1-to-1. We're going to pop this here, right in the center. And we are going to chat a little bit about our operations. Now, once this loads, which my computer, again, sounds like it's about to take off, I'm going to go to Clevance, bclevance.github.io. No, not that one. bclevance.github.io. And hopefully my personal website's going to load. This website has a bunch of information on different things that I do. I also like to keep a checklist of stuff in here. I don't know how much I've updated the Stinger CNC website, to be honest with you, but we're going to chat a little bit about 2D milling and what we can do. We can either follow a vector on the inside, the outside, on the vector, so we're cutting on the line, and you can see where the cutter is cutting out in the yellow here, or we can do a fill. Some places call it a pocket, so fill or pocket, those are 2 ways to describe it. Because we have a 3D shape that we are trying to take an area out of, we technically have 2 pocket operations. We have a pocket operation here, and then a pocket operation here. We then have 1 outside cut. So when we look at it in 2D, we have to start thinking about our vector lines as well as the areas. So again, this outside line is an outer cut if we look at our outside right here. And then if we look here on the 2 inside rounded rectangles that we have, one's a square, one's a rectangle, those are both going to be pocket operations where we clear out this whole area where you can hopefully see my mouse once to a depth, and then again we clear out this area, this innermost shape here, down to another depth. And in my design, I have about a thickness, if we were to look through it at the side down here below, of 0.125, so 1/8 of an inch thickness from the bottom to this surface, 0.5 from the bottom to here, and then that's the full thickness of our piece of material. I could maybe do a section view, but we're not going to deal with that because that's just extra. So once we have this drawing, we can export it. My suggestion to you is export it as a DXF. We may also need to export it as a DWG. I always forget what we utilize when we get off to Cut 2D. So I'm going to export both right now. And technically, if we were going to bring it into Figma, we would probably export as a PDF or one of these 2, and then we would convert it to SVG so that we could actually like start to diagram it. So I have these 2 downloaded. I am not going to designate them as like pockets right now, but traditionally we would want to do that if we're handing this document off to someone else. What we will do next is I'm going to take these files and we are going to hop onto the CNC control box where we will process this in our CAM software. So Onshape's our CAD, computer-aided design software. Where we're going to go next, Cut 2D Pro, to actually tell the machine what it should be doing in areas or on lines or around lines. That's called our CAM, so computer-aided machining software, where we actually start to program what the CNC machine should do. So I will see you in a minute on there.